One of the ways that weather works is through the Coriolis effect. This is one of the effects that has really a subliminal but important effect on every single weather system. This mainly is about the rotation of weather systems in general, as well as the rotation within those weather systems. So let's get right on into it. What is the Coriolis effect? Well, the Coriolis effect describes the deflection taken by objects not firmly connected to the ground as they travel long distances around the Earth. The Coriolis effect determines the rotation of weather systems across the globe. And you can see there in the picture, everything deflects to the right of the equator in the northern hemisphere and to the left of the equator if you're looking at the South Pole in the southern hemisphere. So, why does the Coriolis effect occur? The Coriolis effect occurs because the Earth rotates faster at the equator than it does at the poles. And the exact number here is on the screen on the picture on the right. The Earth rotates at 1,040 miles per hour, which is approximately 1,600 kilometers per hour at the equator, and at 0.0000497 miles per hour at the poles, or on the screen there as 0.00005 miles per hour, which is about 0.00008 kilometers per hour at the poles. So a huge difference in speeds from the northern pole or the southern pole to the equator. So how does the Coriolis effect work? So the best way to describe this is with an analogy. And this is the analogy of a very long game of catch, like baseball. So imagine you are standing at one of the poles and throwing a baseball to the equator. Someone's standing on the equator and you're trying to throw a ball to them. So if you throw the ball straight, the ball will always drift to the opposite of the Earth's rotation, right from the North Pole and left from the South Pole, because the equator is moving faster than the poles. This same thing happens on the way back, as the ball will tail to the right from the equator in the northern hemisphere and left in the southern hemisphere. And as it pertains to weather, there is a very good graphic there on the right, which shows the direction of the air and the deflection that it takes with those red and yellow arrows. Feel free to pause and examine that diagram if you like. So, how does the Coriolis effect impact weather systems? This is the big question, right? So, the Coriolis effect affects air currents, as the currents deflect to the right in the northern hemisphere and to the left in the southern hemisphere. Cyclones, or what we call low pressure systems, they suck air into their center. So they take air from areas of high pressure and move to areas of low pressure. So they're air currents, right? Because you have air moving from one place to another, that is an air current. So in the northern hemisphere, high pressures pass low pressures on the right and on the left in the southern hemisphere. That is just the grand scheme of things, and that impacts like tropical cyclones. In the northern hemisphere, storms move from the west and turn toward the north, and in the southern hemisphere, they move from the west and turn to the south. So there's a Coriolis effect on a very large scale, a global scale. But now we can shrink things down to a system by system scale. So air is also deflected to the right within the northern hemisphere low pressures and to the left in the southern hemisphere, which causes low pressure systems in the northern hemisphere to rotate counterclockwise, and in the southern hemisphere those low pressure systems rotate clockwise because of the deflection of the air coming from both the poles and the equator contributing to those systems. So that is all I have for the Coriolis effect. Honestly, one of the basic principles of every single weather system, but it kind of goes unnoticed. So I hope you all enjoyed, and if you did, consider leaving a like, subscribing, and hitting the bell. That's all I have for today. Thank you guys for watching. I'll see you guys next time.